Hi there. This video is about the suggested solution of MA Economics Part 2, and the subject is Advanced Mathematical Economics. So let's come to the suggested solution of it. This is the question paper primarily. It has about 7 questions, and we have to solve 4 of these. But in this video, we'll try to solve all of these. So let's come to the suggested solutions. The first question is about the definite and indefinite integrals. The first question has the first part which deals with the properties of the definite integrals. So here we have the properties of the definite integral. The first property is that if we interchange the upper and lower limits, the answer will change in terms of its sign. This is the proof of that. This is the left hand side. This is the expansion of the left hand side, and if we take minus as a common factor, it will have reverse signs of these two values, and then we can rewrite them in this way by rearranging them, and we know that this is the kind of expression which can be written like this, where the upper limit and the lower limits, they are mentioned. There is a negative sign as well. So this is the first property. The second one is if the upper and lower limits of the definite integral, they become the same, the answer will be 0. Definitely fa minus fa will be equal to 0, because the difference of the two same values will be equal to 0. Then we have the integral divided into a few parts. For example, if we have a range of values, that is a, b, c, d, and they are in ascending order, then we can write this integral where the first value and the last value are in the lower and the upper limits. Then we can break it down into these parts. For example, from a to b, and then b to c, and then c to d. Definitely it will be the sum which will be equal to this overall integral. So this is the continuity, that a is less than b and b is less than c and c is less than d. This additive property of the definite integrals is evident here, that whenever we have a definite integral, it is the area under the curve, which is divided into various parts, and we can see if we add all of these, we will get the overall area. Then the fourth property is about the coefficient, which if occurs inside the integral should come outside, just like we did in the integration and the differentiation. And then we can solve this the way we have been doing before. The only thing is that this coefficient can come outside, just like it did in the differentiation as well as the indefinite integral. Remaining solution will remain the same. The fifth property is about the sum and difference rule, and it is equally applicable, and we just have to follow the upper and lower limits and solve as we have done in the indefinite integral. Definitely there will be a numerical answer because we have upper and lower limits, unlike the indefinite integrals. So these were a few properties which were the first component of the first question. The second component or part of the first question is about integration of some given functions. This is the given function 2x, it has to be integrated. So these are the various steps that are self-explanatory. 2 coming out of the function as it is a coefficient, and then x is integrated, and the power rule is written here. We already know about this. Applying this, we'll get this answer. Putting it back, this 2 will be cancelled out with this 2, and we will get this answer. This is another question that we can solve by using the integration, the other part of the given question. You can pause the video and see its solution, which is self-explanatory and quite similar as we have seen in the last part. So the third part of this first question is about the economic application of integration on the cost function. We are given a marginal cost function here, and we are also given the fixed cost. So we have to find the total cost. We know that the total function can be obtained by taking the integral of the marginal function. So here we have used the same virtue on the cost function. The marginal cost function is this. We have substituted its value. Its integral is written here. We can recall the rule of natural exponential functions integration. And then this is the consolidated answer. However, this c is an arbitrary constant of integration that needs to be definitized. For that, we use the initial condition, and that's why we consider q is equal to 0 in this given function. Once we do this, we can find the value of the missing part, that is c. So once the output is 0, there will be only fixed cost, there will be no variable cost, and that will be equal to 20 as given before. Therefore, this is the total cost when there is no output. When there is no output, Q is equal to 0. Here, Q is equal to 0. And now we simplify it. We know that total cost becomes equal to fixed cost if there is no output. So instead of this, we write fixed cost, and we have the value of fixed cost, which is 20. So we write its value. Here, natural exponent of 0 is equal to 1. So we simplify this. Now only unknown is C, which is the arbitrary constant of integration. And we have found the value of it, which is 18.89. Now we can put this value of C here in order to definitize the given function of total cost, which will be equal to this. We have just calculated the value of C, and putting it back, we get the answer. So this is the variable part of the cost, and this is the fixed part of the cost. Now we come to the next question, and it has the difference between imaginary number, complex numbers. This is the first part, and it is very easy to understand that whenever we have iota, the Greek letter, in our given function or expression, it will be an imaginary number which is equal to minus 1 square root. That is the square root of a negative value. Now the complex number, as the name goes, is the combination of more than one things, that is the real part and the complex part. So in the complex number, we will have a combination of real number and an imaginary number. As evident from this given example, this is the real part, this is the imaginary part, and the complex numbers. Complex number is a combination of the imaginary and the real part. We can write this minus 3 as square root of 3 into iota, because this minus 1 under the square root will become iota. Now we come to the second part of the second question. Here we are required to convert the given exponential form in Cartesian and polar forms. This is the first part that we need to solve. We know the value of r and theta can be extracted from here. Now this is the solution that we have. You can refer to this video in which we have tried to solve similar questions, and this is the link that you can follow. However, the results are still furnished here. You can watch these as well. Then the second part again requires a similar sort of solution. Again, the link is given here. You can follow this link to see the solution of this. The results are given here as well. Now we come to the other part in which we have to the given Cartesian form into exponential and polar forms. This is the first part that we need to solve. And exponential form, this is the polar form that we can convert, and this is the video that can guide you how to do this. So another part is to be solved. These are the exponential and polar forms of it, and the method is given in this video. You can follow this link for that. Now we can come to question number 3. Price expectation, augmented demand, and supply functions are given. There are no price expectations on the supply side assumed in this couple of equations. So we are to find the time path of price, and we are also required to interpret the nature of the time path. So this is the given set of general form of the demand, supply, price, augmented variants, and we can extract the values of various parameters from this: alpha, beta, m and n, gamma and delta, and then u and w. U and w are 0, so we are given m and n, which are slightly new things that show the role of expectations in our given function. So the double box value of n is positive, and when this is positive, only the distinct real roots are possible, and it means that one of the roots will not be equal to the other. So it is only dynamically unstable usually, but if a1 is equal to 0. You can refer back to the video on the same channel for the detailed explanation of these expressions. So we can only focus on the new part of this question, which is about the various numerical answers. So now we come to the distinct real root situation, because from the theory we know that if n is positive, then we have the possibility of distinct real roots only. So here the formula of the roots is used the way we have been doing before. We have found the value of r1 and r2 by using that formula. Then we can put this set of values in the YC, that is the complementary function, and also the values of alpha, delta, gamma, beta. That will give us the particular integral. Solving these, we get this answer. which is the time path of price, and we can see that this is a distinct real root case. The diagram for this will be like this. And now the next part is, before we come to the next part, a small thing that we must look into is the interpretation. Primarily, the time path was to be found. We did that. But the time path, is it convergent? It is not convergent because one of the roots is positive, that is 5. So if both of them were negative, then we could have convergence. But now one of them is positive, so it does not converge. And with fluctuations, no, it does not, because the fluctuations happen when there are complex roots. Here the roots are distinct real roots, so there are no fluctuations. And the next part of this question is about the application of Raoult's theorem, and we are given a third order differential equation. We can write this and extract the values of various coefficients like a naught, a1, a2, a3, and b. So the first thing that we can see here is that once we note all of these Raoult theorem determinants, the first one is the determinant, which is a1. So a1 has a value of negative, which is definitely a sign of refutation of this condition, and this condition requires that all of the determinants should give a positive answer. So from a1 we can already guess that the Raoult theorem suggests that there is no convergence. So this is one of the hacks that we can use, but it's better to solve it. And we can see that we can develop 3 determinants because the given differential equation is a third order differential equation. Now we try to solve all of these. We have explained these coefficients well in the detail on the same channel. You can look into that. And here the simplification is done, which you can do as well simply by using your calculator. Now this is the explanation that you can see on the same channel. And you can see that first 2 are negative, so the condition is violated because all of the determinants needed to be positive. So we can say that this third order differential equation is dynamically unstable. Now question number 4 requires us to solve the given differential equations using the separable variables method. So in this we separate the 2 variables. Here now after rearrangement, y and t are arranged in such a way that y appears here and t appears on the other side. Now this is very easy to solve because if we take the integral, these differentials will disappear. So taking integral, and then these steps are quite self-evident. How we can differentiate and integrate these are given. You can see similar questions solved on the same channel, that how we solve the separable variables method application on the differential equations. Now the solution will guide us to the answer, and this is the answer of the given question. Another question is given in which we have to rearrange the given data, the equation, and this is again solved by using the similar process of integration and simplification. This is the answer of that. So now we come to the B part of the same question, and in this we have to apply the Bernoulli's equation method to solve this nonlinear differential equation, which is following the condition of Bernoulli equation. That is why on the right hand side the dependent variable y has a power other than 0 and 1. You can get into the details of it by following this video, this link, and the same question will be solved. So you can see the question solved here as well. You can pause the video or you can refer back to that link in order to understand the whole description of this solution. Question number 5 requires us to solve the given difference equations. So this is the first part. Initial condition is also given. So we note this and we try to extract the information. A and C, they are extracted. Since A is not equal to -1, so we can use this formula for particular integral. So the formula of the definite solution will be equal to this. You can refer back to the channel to find out how this formula is applicable. And now putting the values and simplifying, we will get the solution, which is equal to this. Yp is there and yc. Deviation and equilibrium both are there. Now we see that this is a static equilibrium because the equilibrium does not have any variable of time in it. It's just a constant. Another question will be solved, and you can pause the video and try to do this on your own as well. However, the solution is given, a very similar sort of solution that you can do. Part B of the same question requires us to solve the cobweb model mathematically. So this needs to be solved mathematically. We cannot just explain the cobweb model theoretically. So for the detailed solution, you can watch these videos 1, 2, and 3. These are the 3 components of the same video, decomposing the whole video into 3 parts, making it easy. This is just a glimpse of how the whole explanation is done in those 3 videos. So these are quite a bit of detailed set of steps that you can understand from the set of videos given, and the explanation is also there in those links. So the next question requires us to solve the higher order difference equations, and the order is 2 in this case. We extract the values a1, a2, and c, and now we see that the sum of a1 and a2 are not equal to -1, so we can use this formula, which will allow us to get the value of yp, which is 1/4. The nature of roots needs to be determined, and for that we have found the discriminant part, and it is giving a value equal to 0, which shows that there are repeated real roots. And here you can see we have found those roots that are equal to -3 in both of the cases. So collectively we can call them B. This is the formula of the complementary function when it comes to the difference equations. And then the substitution and then the inclusion of the particular integral will make it a time path, which is general in nature. This is the general solution. We can find out the definite solution if we are given the value of y0 and y1. These initial conditions can be used. However, these are not required right now. So this is how we can do this. Again, the solution, similar sort of questions, they are done on various videos on the same channel. Then the B part of it requires us to use the Samuelson multiply accelerator model for the explanation of the interaction between multiplier and accelerator. This is also given on the same channel. You can refer back to that video where all of it is explained in detail. This is the glimpse of the solution, and this is further solution of it, and this is the nature of the roots. Then the final question number 7, it is about the interaction of unemployment and inflation using differential equations, that is Phillips curve. It is already done in this suggested solution of this paper, so you can refer to this link in which you will find the answer of this question. And the B part of it is another non-numerical part, symbolic, theoretical sort of material. So the note has to be written on arrow in the Owen sufficiency theorem. So this is a given account of the theorem, which is more of a proof. So you can pause the video and you can note this. So this is how the whole question paper is solved. And I hope you have found this useful. Don't forget to subscribe if you haven't. Like it, share it. Thank you.